Today we have a very beautiful question from the topic sequence and series. But this one is not a direct summation problem. It is a clever mix of recurring relation, infinite series and a touch of algebraic logic. Let's look at the question. We have a sequence. It defined as a1 equal to 1, a2 equal to 1 and an plus 2 equal to 2an plus 1 plus an, and we need to find 47 times summation n equal to 1 to infinity an over 2 raised to the power of 3n. At first glance, it might look lengthy, but once we observe the pattern and use the concept of generating functions, the entire solution becomes very systematic and easy to follow. So, stay with me until the end. We will simplify it step by step and got a beautiful exact result. Let's begin. Let's take this first one, an over 2 raised to the power of 3n. Here 2 raised to the power of 3n, we can write this as 8 raised to the power of n, isn't it? We did something with an over 2 raised to the power of 3n. Now we have to take this summation n equal to 1 to infinity. So let's take summation n equal to 1 to infinity. So let's name it this as capital T. We substitute n as 1. So then the first one is a1 over 8 raised to the power of 1 is nothing but 8. If we substitute n as 2, the second term is a2 over 8 raised to the power of 2. The third term would be a3 over 8 raised to the power of 3. a4 8 raised to the power of 4 over 8 raised to the power of 4, and so on up to infinity. This is the capital T series. We simplify this part. Now let's take the given condition. What the given condition? an plus 2 equal to 2an plus 1 plus an. So let's take that. In the given question, a denominator we have 8 raised to the power of n. That's why both sides divide by 8 raised to the power of n. Observe the series. Here we have an and here we have 8 raised to the power of n. Here we have an plus 1 and here we have only n, a denominator. So to make it n plus 1, what we do, if you multiply and divide it by 8, then you are going to get 16 an plus 1, a denominator we can write this as 8 power n plus 1, isn't it? Same like that. In the left hand side we have n plus 2 at the numerator and denominator we have only n. So for this, what we have to do? We have to do multiply and divide by 8 raised to the power of 2. This is going to be 64 an plus 2 over 8 raised to the power of n plus 2. So now here n plus 2 at numerator and denominator also n plus 2. Here also same. At numerator we have n plus 1 and denominator we have n plus 1. And here we have a n and here we have a n. Here we have a summation. Summation n equal to 1 to infinity. So that's why both sides you have to take summation n equal to 1 to infinity, and this one also n equal to 1 to infinity, and here also summation n equal to 1 to infinity. Now observe here summation n equal to 1 to infinity a n over 8 raised to the power of n. We consider this as capital T. So that's why this right hand side second term simply we can write this as a capital T. Now we need to observe only the left hand side term and the right hand side first term. First observe left hand side term, which is 64 summation n equal to 1 to infinity an plus 2 over 8 power n plus 2. So that is equal to, substitute n as 1. If you substitute n as 1, then the numerator is, it would be a3 over 8 raised to the power of 3. If you substitute n as 2, then the second term would be a4 8 raised to the power of 4. And if you substitute n as 3, then a5 over 8 raised to the power of 5 up to and so on infinity. Now observe this T series. Let's take it and observe. What is T? T is a1 over 8 raised to the power of 1, it's nothing but 8, plus a2 over 8 raised to the power of 2, plus a3 over 8 raised to the power of 3, plus a4 over 8 raised to the power of 4, and plus so on up to infinity. Now observe this a3 over 8 raised to the power of 3, a4 over 8 raised to the power of 4, and so on infinity, which is same as this one, this part, isn't it? So instead of this part, we can write this as this T minus these two terms, isn't it? Capital T minus these two terms, a1 over 8 minus a2 over 8 raised to the power of 2. So this is the left hand side term. Now observe the right hand side first term. What is right hand side? 16an plus 1 over 8 power n plus 1. Let's take that and observe that. So we can write this as 16. Substitute n as 1. So then we are going to get a2 over 8 raised to the power of 2 plus a3 over 8 raised to the power of 3 up to so on infinity. Now this one also write in terms of a t. What is our t? T is a1 over 8, a2 over 8 power 2, a3 over 8 power 3, and so on infinity. So here we have starting from a2. Here we have a2. So that means this series we can write it as t minus a1 over 8. That is equal to this series. Isn't it? So this series is nothing. If you want to write in terms of a t, that is t minus a1 over 8. So let's write here t minus a1 over 8. So that is the right hand side first term. Now let's take the left hand side and right hand terms. So left hand side what we have? 64 summation n equal to 1 to infinity a n plus 2 over 8n plus 2. So let's take that. That is equal to right hand side first term is 16 summation n equal to 1 to infinity a n plus 1 over 8n plus 1 plus capital T. This 64, the left hand side, after we convert it in terms of a t, so we got this 64 times t minus a1 over 8 minus a2 over 8 power 2. Let's write that. 64 times t minus a1 over 8 minus a2 over 8 raised to the power of 2. Right hand side 16 times t minus a1 over 8 plus t. Now I simplify this. 64 times t, which is nothing but 64t, minus 64 times a1 over 8. Here 8 and 64 gets cancelled, so we left only 8a1 minus 64 times a2 over 8 raised to the power of 2 is nothing but 64. So these two gets cancelled, we left only a2. That is equal to 16t minus 16 times a1 over 8. Here 8 and this 16 gets cancelled, we left only 2a1 plus t. Right hand side 16t plus t, which gives 17t minus 2a1. In the left hand side we have 64t. This minus 8a1 minus a2, if we send to right hand side, become plus 8a1 plus a2. And this t you have to send to left hand side, then it become minus 17t. 64t minus 17t, which gives 47t. So that is equal to minus 2a1 plus 8a1, which gives plus 6a1. So they define a1, a2 well. So a1 is nothing but 1, a2 also 1. So let's substitute. So a1 the value is 1, a2 the value also 1. 6 times 1 is 6 plus 1, which gives 7. Here 47, the capital T we consider this as summation n equal to 1 to infinity a n over 8 raised to the power of n. Summation n equal to 1 to infinity a n over 8 raised to the power of n. 8 raised to the power of n we can write as 2 raised to the power of 3n. So finally 47 times summation n equal to 1 to infinity a n over 2 raised to the power of 3n, the value is 7. That's it. If you like this content, like, share and subscribe to my channel. Thank you for watching.